All right, physics students, today I'm going to do some vector addition, and I've got three different vectors drawn here, and these are going to be the same vectors I use for each of the questions, and this is from your assignment that I'm assigning on Tuesday. So, vector A has a length or a magnitude of 7, and we'll say that's 7 meters so that we know we're measuring something. Vector B, and it's at 40 degrees, and again, that's measured from the positive x-axis. Vector B has a magnitude of 5 with a direction of 80 degrees, and vector C has a length or magnitude of 4 meters at a direction of 150 degrees. Okay, so there are three questions here, and the first one is, how do I add A plus B to get some resultant vector called D? Now, notice I didn't use C for my resultant because I already named a vector C, so I'm going to give it a new name. We'll just call it D to be easy. All right. So the first thing I want to do is I want to draw a picture of this. So what does A plus B look like here? All right, so I'm going to draw vector A first. And I just take that vector A I drew up there before, and I just move it down. Same vector, same direction, same length, approximately. All right, and then B, I'm going to take this vector, I'm going to pull it down, and I start drawing this one. Here on the head of A. So this was A, this is B, and here's that 80-degree angle that B has. All right, and so our resultant vector is the vector that goes from the beginning of A up to the end of B. So that's vector D. All right, and we want to know the length of that, and we want to know the direction of that. So that's theta. Okay. Okay, well, in order to do that, I need to know what the components of D are. And so vector D will have an x component, D sub x, and it will have a y component, D sub y. All right, well, I don't know what those are, but I can figure those out if I break A and B up into their components. So let me make A a different color here. Here's A, and A has an x component right here and a y component right here. And then vector B will make purple, and that has its own x component and its own y component, B, y. All right, now if you look at this, AX and BX, the length of this and the length of this goes from here all the way to the end. So that's DX. So therefore, DX is AX plus BX. And we see the same thing for DY. Okay, here's AY, DY. From here to there, that's DY. So DY equals AY plus BY. The Y components add together. So you can add like things together. Y's go with Y's, X's go with X's. I just cannot add A plus B and go 7 plus 5 equals 12. That's not right. Okay, so what I need to do now is I need to figure out, I don't know AX and BX or AY and BY, but I can figure those out from their triangles. Okay, so let me draw A out here. Again, I only do this for your benefit. If I was doing this on my own, since I already know what to do, I wouldn't have to redo all this, but I'm making it go longer so that you can kind of see my thought process. All right, so how do I find AX? I know this angle is 40, and I know that AX is the adjacent side to the hypotenuse. So adjacent goes with cosine. So the cosine of theta equals the adjacent side over the hypotenuse. Oops, shoot. There shouldn't be a subscript there. AX over A. I want AX by itself, so let's get rid of A by multiplying both sides. All right, and then I go 7 meters times the cosine of 40 equals AX. So let's get out the calculator here. And I go 7 times cosine 40, and I get 5.36. All right, so that's AX, so I'm going to put 5.36 right here, because that's AX. All right, now let me do AY. AY is the opposite side of 40, so that's sine. So I say the sine of theta equals AY over A. All right, that A is the hypotenuse. So again, we want to get rid of A and get AY by itself. And so then I plug my numbers in. 7 times the sine of 40 equals and I get 4.5. So I'm going to come up here and just write 4.5. Okay, so I'm on my way. Now I just need to know what the B components are. So let's change our colors up here. And BY, the B triangle, sorry, looks like this. And this is 5, this is 80 degrees. So this is BX and BY. Okay, it's the same process as before, just with different numbers. So BX is the adjacent side to the angle, and so that's cosine. So the cosine of theta in this case is going to be BX over B. Multiply both sides times B, and that's going to be 5 times the cosine of 80. So I go 5 cosine 80 equals 0.868. So that is definitely not drawn to scale, but that is the correct answer here. So for BX, I'm going to put plus 0.868. Okay, and then for BY, BY is the opposite side. So again, this is sine. So the sine of theta in this case is going to be BY over B. Multiply both sides by B, and I get 5 sine 80. All right, well, that's going to be a much larger number. So 5 times the sine of 80 equals 4.9. Okay, so I'm going to put 4.9 right here. So then what does dx equal? Dx equals 5.36, so it's 0.868. That's 6.2. And what does dy equal? 4.5 plus 4.9, that's going to be 9.4. So now we have the two sides of our D triangle. All right, and let me just draw the D triangle out again by itself, so we get rid of some of that clutter. Dx equals 6.2, and dy equals 9.4. We don't know that angle, but first thing, let's find out what D is using the Pythagorean Theorem. A squared plus B squared equals C squared, or dx squared plus dy squared equals D squared. So dx is 6.2 squared plus 9.4 squared equals d squared. All right, so 6.2 squared plus 9.4 squared equals 126.8. And if I take the square root of both sides, then I get what d is actually equal to. So the square root of my answer there, and it is 1.13, or I'm sorry, 11.3. All right, so that is the length of d. Now the other thing we want to find is that angle, okay? And again, I can do it, I know that this is 11.3 now, so I know all three sides of a right triangle, and I can use any trig function to find that angle. So let's just use, I guess I use tangent regularly, so that we know that the tangent of that angle is equal to the opposite over the adjacent side. So 9.4 divided by 6.2. All right. I don't want the tangent of that angle, though I just want the angle. So I have to untangent it by using inverse tangent. But if I use inverse tangent on one side, I have to use inverse tangent on the other side. So I have the inverse tangent of 9.4 over 6.2. So on my calculator, I can hit second tangent and then go 9.4 divided by 6.2. Hit the parentheses there, and I end up with 56.6 degrees is theta. All right, so my final answer here is d is a vector that is 11.3 meters long at 56.6 degrees. And that looks about right, right? Okay. Okay, let's move on. So that was a plus b equals d. Now, let's go to the next one here. All right, so a plus c equals e. So this time, I'm using the a vector here and the c vector here, which is going off in a different direction. What happens in this case? Okay, so a plus c equals e. All right, so this is going to be, let me draw my axis here. Vector A, once again, is 7 at 40 degrees. And then vector C comes at 150 degrees and it's only 4. Now, I'm just going to draw a dotted line here. I'm going to say that that's 4. Okay, again, I'm just kind of eyeing this up. And so then where is this is A, this is C. So my resultant is from the beginning to the end. This is going to be E. All right, and again, we don't know what that is. But I do know that this is 150 degrees. I know this is 40. I know this is 7. I know that's 4. So we do the same thing even though the triangle looks a little bit different. So I know that if I want to find E, I need to know its y component, EY, and its x component, E sub x. All right. In order to find those once again, I need to know what the components of the other vectors are. So let's look at A again. Here's A in pink, and the AX vector, which comes all the way out here, and the AY vector, which goes here. All right, now you might be saying, well, how are we going to have an AX bigger than EX? Well, let's take a look at vector C. Once again, vector C is going up and to the left. All right, so that means its X component is moving left. And what does that mean? That means that that is going to be a negative number. Then we come up here, here's cy. All right, and now let's pull those two triangles out, because again, going all the way over here for ax and then coming back to cx is ex, right? So I'm going to pull those triangles out. All right, now here's the thing. We did the vector components for a in the last problem, so I'm not going to redo those. I know that ax is 5.36, and I know that ay is 4.5. All right, so I know that. So let me do c now. Okay, c sort of comes the other way. So here's cx, cy, and c. C is 4, and the angle is 150 degrees. All right, and you might be saying to yourself, wait, we have a 150-degree angle here inside a triangle? That's not right. But let me just show you how this works and how the numbers will work out for us. Okay, so once again, if I want to know what cx is, that's the adjacent angle, or adjacent side to the angle. So I go cosine of theta equals my adjacent side over my hypotenuse. Once again, multiply both sides by the hypotenuse to get rid of it. And so then it's c cosine theta. So I go 4 times the cosine of 150. And the nice thing about cosine is when you are greater than 90 and less than 270, guess what it comes out as? A negative number. So I go 4, oops. So I go 4 cosine 150, and I get negative 3.46. So this equals negative 3.46 for cx. All right, and then I'll do the same thing for y. Now this is still moving upward, so that's going to be a positive number. That makes sense. So sine theta equals cy over c. Multiply both sides by c again, and we get 4 times the sine of 150. Anything above the x-axis for sine is positive, so that makes sense. So we go 4 sine 150, and I get 2. Okay. So we've got numbers here. Ex, if I pull this triangle out, will look like this. And Ex is going to be Ax plus Cx. So let's put those numbers in. And we get 5.36 meters plus, well, what was Cx? Cx was negative 3.46 plus negative 3.46. And so pull this out here, 5.36 minus 3.46 equals 1.9. So Ex is 1.9. Ey will be Ay plus Cy, and that's going to be 4.5 meters plus 2 equals 6.5 meters. That's Ey. All right. So Ex is 1.9, Ey is 6.5. To use the Pythagorean theorem to find E, we go E squared equals Ex squared plus Ey squared. All right. I'm going to just right away take the square root of this since I know that I want only E. So that's going to be 1.9 squared plus 6.5 squared And so I'll take the square root of 1.9 squared plus 6.5 squared, and that's 6.77 meters. So that's the magnitude of E. And then again, to find the, we know that this side is 6.5, we know this side is 1.9, and we know that this side is 6.77. I know all the sides. To find this angle, let's use tangent again. So the tangent of theta equals opposite over adjacent, 6.5 over 1.9. But I want to get rid of the tangent, so I go inverse tangent of this. And so theta equals the inverse tangent of 6.5 divided by 1.9. And that's 73.7 degrees. And that also looks like it makes sense, right? That's a pretty steep angle. All right, last one. Last one is A minus C equals F. All right, so what's this business subtracting two vectors? Okay, well, when we subtract a vector, we take that vector and we make it the negative vector. So just a reminder, this is A. A is 7 meters at 40 degrees, and C was 4 meters at 150. All right, well, what's negative C? Negative C is this vector if I put the arrowhead on the other end. So I'm going to draw it this way. And that's my negative C. The orientation is still the same, the length is still the same, but what's this angle now? Okay, well, there are two ways we can look at this. We can start at our x-axis and come all the way around, and that's going to be 330 degrees. Let's use negative 30 instead, okay? That makes a little more sense in my book. So, when I add these two vectors together, I'm going to not be putting it together with this vector, I'm going to be putting it together with this one. So let me draw my axis out again here. All right, and I draw out vector A, 7, 40 degrees, and then negative C is going to come down. Now, I don't know, I think it might actually come down below this axis, I'm not sure. Well, if I had a protractor, I could actually do this one, but I just don't know. It's not super important that I know that either. I just know that this is a negative 30-degree angle. When I do the math, I'll know exactly whether my drawing is right or not. Okay, and this is, again, 4. So what's the resultant vector F? Again, that goes from my start to my finish. So this is vector F. All right, so let's once again reiterate what we already know from the previous problem. We know that AY is equal to what did I do with that? I know AY is equal to 4.5, and I know that AX equals 5.36 meters. Okay. What do I know about C? Because we used C in the last one, we didn't use negative C, but there are a couple things we can know. The lengths of the components will not change. CX, CY, okay? The difference is now, and here's my C triangle. Okay, CX is going to be the same length, but look which way it's going now. It's going to the right, which means that before, when it was, what was it? CX was negative 3.46. Now it's going to be positive 3.46 meters. CY is going down this time. So CY last time was 2 meters. So now it's going to be negative 2 meters. Okay, so a lot of the work was already done here. Now to find that last triangle here, F, okay, so here's the F right triangle. Let's pull that out. It's a very thin triangle. Here's Fx, here's Fy, and here's F. And we don't know this angle either. This could be wrong. It could be flipped upside down again. I don't know exactly what the numbers are going to turn out to be. But let's find F using the Pythagorean Theorem. I know that F squared equals Fx squared plus Fy squared. And I take the square root of both sides. Oh, wait, there's a problem. We don't know Fx or Fy. But we know that Fx is Ax plus Cx, or negative Cx anyway. And so that's going to be 5.36 plus 3.46, and that's going to equal 8.82. Fy is going to be Ay plus negative Cy, and that's going to be 4.5 plus negative 2, and that's going to be 2.5. Oh, so that's a positive number, so I did draw this wrong. This angle, this blue one should have been like this. I'll draw that at the end when I'm done. All right, so let's figure out the length of F. Square root of 8.82 squared plus 2.5 squared equals 8.82 squared plus 2.5 squared equals, take the square root, and I get 9.12 for F. What's that angle going to be? Let me redraw that triangle correctly. This is going to be F. This is Fx. This is Fy. This we just found out is 9.12. This is 2.5. And this is 8.82. So this is the angle we're trying to find. I've used inverse tangent before. Let's just use inverse sine this time. Why not? We have all sides. So I know that the sine of theta equals my opposite side, Fy, over F. All right? So the sine of theta equals 2.5 over 9.12. Let's take the inverse sine of both sides because we don't want the sine, we want the angle. And so pull out my calculator. I go the inverse sine, second sine of 2.5 divided by 9.12 equals 15.9 degrees. And that makes sense. Okay, that's a very thin, small angle. That's a very small angle there. All right, so that would be A minus C equals F. F is 9.12 meters at 15.9 degrees. All right, that's the homework.